Hello everyone. This experiment we're going to do the heat of a neutralization experiment. We are going to measure the heat transferred from a neutralization reaction, which is a reaction between an acid and a base, producing salt and water. So in this experiment, the acid used is a weak acid called oxalic acid. It's H2C2O4. And the base used is a strong base. It's called sodium hydroxide. And here is our water and our salt. And the heat from this reaction, whether it's released or absorbed, is going to be measured from a calorimeter. It's an apparatus that measures the heat involved in a physical process or chemical process. Now I'm going to show you briefly how to run this simulation for our experiment. First of all, you should have already opened the data sheet from Canvas and created the data tables in your notebook as suggested from this data sheet for recording your data. Now you're ready to open the simulation, and you can find the link for this simulation in the data sheet and also on Canvas. Let's click on Experiment, Run Experiment. Here, you see a beaker on the left. Let's put our first solution into the beaker. Let's pick our oxalic acid. And the volume, let's put 100 milliliter into this beaker. And the molarities of our solutions, both acid and base, are 1.00 molal. Let's give that value to the molarity. And click on Show Specific Heat. Now, notice this 1.84. This is the same value as the specific heat of pure water. It's based on the assumption that the small amount of solute added to water does not change the specific heat capacity of water. All right, what's on the right here? This is what we call the perfect calorimeter. A perfect calorimeter means that the apparatus will not absorb heat from the reaction or release heat to the surrounding. Simply put, the reaction took place in a perfect calorimeter is perfectly insulated. So in turn, we will be able to accurately determine the heat involved in the chemical process happened inside. All right, the temperature of the solution is measured with this the temperature probe here. And solution is also stirred with a stirrer in order for the heat to be distributed evenly in the liquid. All right, let's add our second solution here. Click Next first. All right, let's add our base into our calorimeter. Let's click Next, Solution, and pick our base, sodium hydroxide. Again, the volume, let's pick 100 milliliter. Molarity remains 1.00 molal. Show specific heat is 4.184 based on the same assumption. All right, now we are ready to mix the two solutions. Let us click on Next. All right, before you click on Start, let's go ahead and check Show Graph View. So you can see a temperature change versus time. All right, now let's go ahead and click Start. As you see from the graph and also from the temperature probe here, the solution gets hot. The temperature keeps climbing and then now reach a plateau. This is indicating the reaction stopped giving out heat. And this temperature, once it stopped, we need to record as our final temperature. It's worth noting that the graph here is not a real-time graph. In real life, this process is going to take at least a few minutes. All right, this is the end of our trial 1. To start the next trial, we simply click Reset. It's just as if you were Harry Potter, waving your magical wand and all the disposal and cleaning up are done. So you're ready for your next trial. Like this. For the next two trials, the only change is the volume of the oxalic acid. And you can follow the suggestion in the procedure to change the volumes. I hope this video helps.